Okay, welcome everyone, and thank you for taking your coffee break with OpenText Portfolio. My name is Doug Stewart, and I'm a Senior Director of Solutions Consulting here at OpenText. And in today's episode, Jacqueline Probe and Matt Lupfer will discuss the benefits of application containerization and Kubernetes. Jacqueline and Matt will share their knowledge and hands-on experience working with these powerful and promising technologies. So welcome, Jacqueline and Matt. Why don't you each take a minute to introduce yourself to our audience, and why don't we start with you, Jackie?
Sure. So I'm a senior solutions consultant here at OpenText, and I've been supporting portfolio products and solutions, and I've been with OpenText since 2004.
Excellent. And Matt?
Hi, my name is Matt Lupfer, and I am a software engineer and consultant based in Asheville, North Carolina, and I've worked on some cloud migration projects and containerization projects, and I look forward to the discussion.
Excellent. Well, welcome you too, and I'm definitely excited to explore this topic with you today. So let's just jump right in. So, Jackie, we'll start the questioning with you. So kind of starting with the basics, what is application containerization?
You know, application containerization can be considered like a package of lightweight software components that really bundle the application. So all of the dependencies, that includes the configuration, and it all is bundled into a single image running in an isolated, efficient environment. So you can think of it as rather than spinning up an entire virtual machine, so with all the infrastructure behind to run that application, instead the container packages together everything. So it needs to run just a small piece of the software in a container. It includes the code. It also includes the dependencies, configuration, like I said, and even those operating system components like libraries. So it allows the application to run efficiently almost anywhere.
Got it. And one thing that I hear a lot about is Docker and Docker and containerization, and they're kind of mentioned interchangeably. But is containerization and Docker the same thing?
Well, as I mentioned, the containers are those application bundles that are in a single isolated environment, where Docker really automates the delivery of the application. So it provides an abstraction layer and an automation layer for the OS level, the virtualization of that OS level. So Docker is really essentially a runtime for the runtime engine for those containers. So it's, it packages together the applications for distribution, it automates the delivery of them, and then it condenses the infrastructure so it can be more manageable.
Got it. Okay. And then, so Jacqueline, I guess my next question is why do this? What are the benefits and advantages of, or what benefits and advantages does containerization bring to, say, my organization?
Well, benefits of containerizations and container runtimes. So you have the speed. So containers are smaller entities than, of course, the virtual machines. They're components of the application, so they can be deployed much faster. And so I talked a little bit about isolation of those environments. Isolated really means responsive. So startup times are really short. And then isolation means versatility. So containers are really portable between different platforms and different cloud vendors. So just to jump in a little bit further, when applications are created and when software is deployed, oftentimes organizations are not aware of the places they need to be deployed. So today, an organization runs on-prem or really might be in a private cloud, but tomorrow they might need to deploy it on a public cloud or even move providers. So containerization and runtime engines really allow the organizations with that flexibility, so they can handle the demand of all of those diverse environments with a single package. So you have a layer of containerization, you have a layer of a runtime engine, and then you need an orchestration layer, and that is brought to you typically by Kubernetes, which is open source, and it allows you to deploy, it allows you to scale and run and monitor those applications. So I know someone just gave me this a really clever term the other day, but you can think of it as a cloud operating system. And the real key thing is that it's vendor independent.
Got it. Okay, so I guess Matt, Jackie just brought up Kubernetes. What is what is Kubernetes?
Sure. Kubernetes is a software project from Google that is focused on running containerized applications at very large scale. So the initial adoption of Docker in the early 2010s was focused mostly around developers and test environments, and there became a need to deploy these applications in production environments at scale. And so Google, which had been doing containers at scale for a long time, started this project Kubernetes as an open source project. They donated that project to the Cloud Native Computing Foundation, which is part of the Linux Foundation. And what Kubernetes aims to do is to be able to provide a distributed clustered environment with high availability for containerized applications running on commodity hardware with the enterprise features that you need at that scale, like rolling upgrades and rollbacks, self-healing, health monitoring, isolation and multi-tenant environments, and just extreme levels of scalability. So you can do things with Kubernetes pretty seamlessly, like taking a node out of the cluster for maintenance, and Kubernetes will just reschedule the workload on other nodes as long as that node is down, and then you can rejoin the cluster after that and start having work assigned to that node. So orchestration is clustering and scheduling and provisioning. It's a level of OS-like features that are essential to make these container workloads operate at scale. So there were, for a short time, there were some competing standards for container orchestration software. Docker had Swarm. There was a solution called Mesosphere, and those things still exist, but Kubernetes has become the de facto orchestration layer in the cloud. And all of the major cloud service providers provide some level of container engine, which provides all of the runtime and tooling necessary to deploy containerized applications and workloads in the cloud.
Got it. Hey, one thing that I didn't think of, earlier was that this containerization piece has been around, as Matt, you were just pointing out, for it sounds like 10 years or so. And what about the orchestration side? How long has that been around? The same length of time, or?
It's been around as proprietary technology for the same length of time. The enabling technology for containerization is a feature called control groups in the Linux kernel. So control groups allow the kernel to provide separate namespaces for different kernel infrastructure, so that you basically get a nice, very lightweight, quick provisioned VM, essentially. You don't get the exact same hardware isolation guarantees that you would get with a VM, but you get very, very many of the same benefits. So orchestration became a must-have to be able to scale these installations up. So it's been, I think behind the scenes they were kind of developed in tandem, but it was really the introduction of Kubernetes and its open sourcing that really made it take off in the commercial space.
But I mean, it's been around a decade. This isn't 2020 technology. This is mature and vetted technology, it sounds like.
For sure.
Great. Hey, Jackie, so kind of building on what Matt was just talking about with Kubernetes, he went into kind of teased us with some of the benefits and advantages of Kubernetes, but what again, the why question, what benefits and advantages does Kubernetes bring my organization?
Well, it was good to hear the kind of the background there, because you can think of the application Kubernetes itself managing the container, the applications itself, and the container traffic and performance. So that is an advantage right there. But when you have distributed components across various infrastructures, the ability to manage that is really key. You have the ability to scale up deployments as well as upgrades. And Matt also mentioned the self-healing aspects, especially when you roll in Helm charts and the automation behind there. You know, the ability to have the infrastructure as well as the networking with the ingress controllers and orchestration of all of that. It's really key. So being able to easily deploy, I know we talked a little bit about just the self-healing, and then I mentioned Helm, but being able to quickly deploy content and applications itself with ease of use Helm charts. Kubernetes rolls that into its infrastructure, so it makes it very efficient.
Got it. And Matt, I know you have several kind of hands-on stories and use cases that you've made use of application containerization as well as Kubernetes. Could you share like one or more of those?
Sure, yeah. The biggest project I've worked on was a proof of concept in migrating a VM-based test infrastructure for a large development team from like I said, the VM model to containerization. And what we found with so I worked for a storage vendor that makes petabyte scale custom storage solutions used primarily in supercomputing applications. And so the hardware that we had was highly customized and very expensive. And we had developed over many years a large test suite to run on that hardware. But that doesn't scale because we just did not have the resources in R&D to be able to run on the hardware all the time. So we had developed a way to test much of the software in emulation, which is what we referred to as running in a VM. But it was an embedded software application. It had pretty strict real-time requirements. So the VMs were hard provisioned to have a certain number of physical CPU cores, a large amount of memory, and there are about 400 tests. So to get through the test suite, it would take 3 to 4 days. So we would bundle up all of the changes that the engineers had made in the previous 3 to 4 days and kick off a test cycle. And we had a lot of custom infrastructure code that wasn't very resilient that we used to distribute those tests across these large VM servers. And so as we got to looking at that and looking at ways to replace it with something more modern, it became pretty clear that we could get rid of all of our custom infrastructure code that wasn't resilient to failure, we could lose days of test cycles just due to one infrastructure failure, like a system going down. So we took all of that intelligence out of what we were working on and just relied on Kubernetes itself to schedule the tests. So we could just have a declarative list of tests with their arguments, feed it into the Kubernetes scheduler, and have it test on any kind of hardware. And if a test failed for infrastructure reasons, the test would be rescheduled and run somewhere else, and it'd be completely seamless. If we had to take a node out of the cluster for firmware upgrades or hardware replacement, you just do it. You just tell the Kubernetes cluster that not to schedule any work there, take it down, and bring it back in. So we realized a lot of savings. We got the test cycle down to something on the order of 12 hours instead of several days. Wow. And primarily that's because rather than provisioning these hard provisioned VMs and running the tests and then tearing them down, we just had these ephemeral containers that we could take the latest version of the code that we wanted to put under test, compile it, and then distribute it through a container registry to the entire cluster where extensive caching occurs just automatically. So instead of having 5 minutes of setup for every test, we got it down to something like 5 seconds because the container boots pretty much instantaneously. So the other thing we got to realize with that is much better system utilization. We measured the utilization of the old method at about 30% in terms of CPU resources and memory resources in the cluster. And we got something much closer to 90%. Kubernetes has a really extensive set of features for monitoring resource utilization and placing containers efficiently on nodes where the correct hardware is present. So we got much denser test runs. And so this, for the managers who were managing these software releases, it gave us the opportunity to no longer have to plan around the testing, like as we had deliverables due, software releases scheduled. It always became a big question of when do you start the tests, because you might need to run them a few times, they might not complete successfully, and it takes several days. So it gave freed up managers to worry about actually getting the changes and fixes in that were needed for the release, rather than worrying about hand-holding the test infrastructure.
Nice. Great. Well, yeah, you definitely touched on all the big three, time, cost, and risk. Interesting. Well, Matt, I know that you did some, and Jackie, I think you've done the same, bootstrapping to kind of learn more about, get started and then learn more about Kubernetes and containerization. So Matt, how does somebody get into this? How do they get started when it comes to learning more about containerization and Kubernetes? What resources or hyperscalers, or how do you get involved?
Sure, yeah, there are a lot of good options. Kubernetes is designed to run in a lot of different environments. It can run on bare metal, it can run in VMs, and it can run in Docker, where Docker containers act as nodes. So that would be a smaller scale test environment or a sandbox to play around in. But essentially, I would recommend that people focus on the technologies and tools they're already familiar with. And if they're already familiar with VMware, then find a tool that lets you use VMware as the backend. If you're already a container person and you like to run services in containers, use something like Minikube, which is a Google project that'll bootstrap a small cluster just on a single workstation with Docker. And if you're a person who likes to get your hands on hardware and you've got the hardware around, one control node and 3 worker nodes is pretty much all you need to get off the ground with a Kubernetes cluster. So there are distributions like Red Hat's OpenShift, and Rancher Labs has Rancher that provide really good tutorials, instructions for bootstrapping on bare metal. So there's a lot of good options.
Well, excellent. Well, believe it or not, that's pretty much all the time we've got today. So with that, Matt and Jacqueline, thank you for being with us today and sharing your experience and expertise on this topic of application containerization in Kubernetes. And also to our audience, thank you for listening today. If you have any follow-up questions or would like to talk with one of us, please contact us at the igc_@opentext.com email address. Again, thank you everyone for joining us today, and special thanks to Jacqueline and Matt for sharing their experience with containerization and Kubernetes. So have a wonderful day, and we'll see you at the next coffee break with OpenText Portfolio. Thank you.